Um, Hi everyone, I'm Ali. I have built Neural Control Bench, a hood oral environment for neural stimulation control, where agents learn to safely drive neural-alike systems to target outputs. Before I go too deep into the product and slides, I want to talk about the motivation that got me build this. On the hackathon page, it said build environments for 2040. So I started from 2040 and worked backward. I believe in 2040 we're going to have a lot of biocomputers. If that hypothesis becomes true, we're going to need an environment where LLMs could work with biocomputers. And that's the whole hypothesis behind this project. So what I have tried to do is build a black box system where we could ask LLMs figure out the settings that are needed in biocomputer to accomplish the task, and we reward the system based on how many times it has achieved the required task. Now, you would wonder what are the settings that need to tweak. There, so going into a little bit biocomputing, the way it works is regardless of your problem space, whether it's robotics, generic writing recognition, or speaking, playing games, whatever that field is, it has to be converted into electrical signals of certain frequency, intensity, duration, region, and so all those knobs have to be turned in a specific setting, which is very hard to find. So what I have tried is ask LLMs, hey, these are the few knobs that you can turn, and this is the output that I'm looking for. Go turn those knobs and give me the output that, give me the settings that satisfy the output. I have been able to get promising results, but there are a couple of things that need to be proved later on. Everything was done on simulator because I did not have lab-grown neurons at the time. However, this program could be utilized on the actual neurons in the future. The product that I built is pretty generic. It could be utilized for neurotech, biocomputing, robotics, industrial automation, healthcare, and frontier AI labs because it does not matter to biocomputer whether it's a particular industry, because at the end of the day we would have to encode all that information into electrical signals of various frequency, intensity, length, duration, and spatial information on the dish. So it will work for all those industries. Let's go and take a look at the product. This is how the interface looks like. On the top, I clearly say which ones are verified and working and what's not connected and not available. On the toolbar over here, we could set different targets. Targets are basically I have hard coded like what sort of intensity, amplitude, frequency, and different parameters that I'm looking for. We could seed the data and then load all the data and hit run. It's going to go through its steps, and then it told that the LLM figured it out. And here is very important results. I have tried to compare the LLM performance with different traditional algorithms such as random search and safe climber. However, LLM beats them with high performance. And we can go and take a look at the job on Hood. It's all available. So we can see the job right here. So this is what I have built in the last 12 hours. I think the bet is on biocomputing, and my whole hypothesis is if biocomputing becomes available, do we have environment where LLMs could work with biocomputers in safe and controlled environments and learn over the time? And that's what I have built. Thank you.